Alrighty, this is second part of nuclear physics, starting with the fundamental particles. Okay, so this topic is going to be purely 100% based on your memory, as mentioned in the first part of this video as well. So before we start with this, please be careful that this is nothing to think about. This is purely based on memory. You have to memorize everything. आपने सब कुछ इसमें याद करना है, समझने वाला इसमें कोई इतनी ज़्यादा चीज़ें नहीं है, and we are going to look at questions as well, and you will see that they are based on memory, nothing more. Okay, so moving on towards elementary families, we need to first memorize what are the fundamental particles. Before this, we thought that protons, neutrons, and electrons are fundamental particles. They're the elementary particles. Nothing can be smaller than that. Basically, unse chota aur koi nahi ho sakta. So everything is probably made out of those things, but they are the building blocks. But with the Large Hadron Collider, we realized, and we were able to break them apart as well, and we realized that no, there are some particles that are even inside those protons and neutrons. What are those particles? And so that's why this whole discussion of fundamental particles actually started. That we had the evidence that इनसे छोटा तो और कोई नहीं है, but जब Hadron Collider को देखा तो पता चला कि ये इनसे छोटी भी चीजें हैं. There are things even smaller than this. So what could be those things? So we then started to divide them into families. Now there are many type of families, but the only families related, or the fundamental particle families according to A levels, are these ones. So the first family is leptons. The next family is hadrons, right? Now, let's see what are leptons. So leptons primarily consist of electrons, primarily as beta negative particles, and neutrinos. What are neutrinos? We'll get to that later. Then anti-neutrinos, right? And positrons, which are antiparticles of beta. So they're referred as beta positive decay. That is why I was not discussing this in the first part, because it's a very broad topic. Leptons is a very broad topic. So I will cover beta decay, quark models, and everything related to this topic in just one go as a part of this video. Now let's talk about hadrons. What are hadrons? So the second family in the elementary particles is hadrons. Now hadrons are those particles which are made out of quarks, right? Leptons are not made out of quarks. They are a family themselves. Right? Now, again, if you go online and research, you will find that there are many branches of this fundamental particle or elementary particles in which quark models are also making other family members as well. But we are not interested in those because that's not a part of this course. Anyways, so what is special about hadrons? What are they? Now, hadrons are again divided into two families or subfamilies. First family is mesons. The second one is baryons, right? Now, what is special about, what is the thing to remember about meson is that they consist of 2 quarks, and baryons consist of 3 quarks, right? Now, they could be in any fashion, they could be in any flavor, they could be in any format. What are those quarks that are supposed to be a part of your course? We'll get to that later. But first, what we need to remember is that they will have 3 and mesons will have 2. But in what configuration? Now, this is also a part of the memory. Mesons will have 1 quark itself and 1 anti-quark of its counterpart. Now, what is antiparticle? What is antimatter? You see, what we need to remember, or what we need to at least memorize, is that if, for example, we have a beta particle which has, let's say, a negative charge, a negatively charged electron, for example, then we know that its charge is minus 1.6 into 10 raised to the minus 19 coulombs. And we know that the mass of electron is 9.11 into 10 raised to the minus 31 kilograms. This is also mentioned in your data booklet when you start with your paper. Let's say that we have another particle, which we don't know what it has. What are the credentials? It has the same mass as the electron, minus 31 kg, but it has a charge that is positive, which is opposite to the electron. So matter and antimatter, what's connecting them? What's similar between them? They have the same mass, but they have exactly 100% opposite charge, right? So a meson will have a quark itself and an anti-quark. Now the next slide will contain what are quarks itself, what are the building blocks of these hadron family members. But what we need to remember, 3 quarks, 2 quarks, and what are the quarks themselves, and what are leptons. Okay, let's move on to the next slide. You can probably pause the video in these locations, and you can just take a screenshot for your own notes, or you can write them down on your notebooks, because I've organized them in such a way. Now you will see that electron is actually the beta negative, and positron is actually beta positive, or called or referred to as beta positive. What is different about them? What is the difference between them? They will have the same mass, but they have opposite charges. So electron is a matter and positron is antimatter. Anyways, moving on. With every beta emission, you will find an anti-neutrino emission, and with the positron, you will find a neutrino emission. How did we get to this? How did we realize this? I will get to that later. But anyways, these are the lepton family members. There are more than this. You can go online, search about them, but that's beyond the scope of this class at least. Moving on, we have quark flavors. Now, this is what you are supposed to memorize. ये आपको याद होने चाहिए कि up का charge क्या है, charm का क्या है, top का क्या है, and what are the symbols that we use them to represent, and down का क्या है, strange is -1/3 and bottom is. Now, what is this E? E is the elementary charge, which is 1.6 into 10 raised to a -19 coulombs. We already know that. So this up is actually 2/3 of this charge, and similarly charm as well, similarly top as well. Now, this is a point of discussion that we believed that charge is quantized. In electricity and in A2 physics at least, we understand that charges cannot be broken down into smaller parts. But in quarks, we see that they can be. You can search about this online as well. Anyways, ये आपको याद होना चाहिए. ये आपकी memory का part होना चाहिए. There is no doubt about this. This should be a part of your memory. Anyways, so let's go on. Let's move on with the composition of two quarks that we already know. Because जब हम यहाँ पे वापस आते हैं ना baryons में, hadron baryons में, so there are two that are part of you, that you've already done, that you've already learned, but are part of your memory as well. So baryons में कौन कौन से आते हैं? Protons and neutrons. So yes, they are made out of quarks. And how many quarks they will possess? They will have 3 quarks each. And we are supposed to know their composition as well. So let's write that down as well. So proton is made out of 3 quarks, but uske upar overall charge kya hai? +1e. So it is actually made out of 2 up quarks and 1 down quark. How would you calculate this? So up quark pe we have a charge of +2/3. So a proton has up, up, down. So that will be +2/3e +2/3e -1/3e. So दो उसमें up है और एक down है. जब आप इसको फ्रैक्शन को ऐड भी करोगे तो आपके पास आंसर आएगा 1e, यानी +1e. So proton के ये quarks होते हैं, we should remember them, right? And जो आपके पास neutron है, neutron has a neutral charge. It has no charge. But let's see how it goes. It has 1 up and 2 downs. So it is +2/3e -1/3e. This is what we are picking the values from. This is down and this is up. -1/3e. And you will get an answer of 0e. That's how it is neutral, right? So हमें बाहर से तो लगता है कि न्यूट्रॉन पे कोई चार्ज नहीं है. This is the misconception. न्यूट्रॉन के अंदर क्वार्क्स मौजूद है जिन पे चार्ज है, but overall charge क्या है? 0. So anyways, we've also memorized the quark composition as well. So पहला part क्या है syllabus का? We need to understand that there are 6 flavors. Up है, down है, strange, charm, top, bottom. ये हमने flavors को देख लिया. इनके ऊपर जो charges हैं, we've also observed them as well. He says, recall the charge flavor quark, understand respective anti-quark has the opposite charge but same mass. We know matter and antimatter as well. That masses should be same but charges can be opposite. Third part is recall that proton, neutrons are fundamental particles but described as in terms of their quark composition. और ये अभी हमने किया है कि protons और neutrons quarks में कैसे represent होते हैं, and they also belong to the family of baryons, right? Anyways, then we have point number 4. We need to understand that there is a hadron family. Baryon consists of 3 quarks, meson consists of 2 quarks, 1 quark and 1 anti-quark. So there are basically 2 quarks. We also memorize that as well. Now we are left with beta decay, and we're left with beta decays with leptons of neutrinos and antineutrinos. But let's move on to that topic. So ये सारा आपने याद करना बेटा, ठीक है? This is supposed to be a part of your memory. This is supposed to be a part of your memory. और अब हम इस पे बात करेंगे, the topic that I've been lingering on for so long, the decay of beta negative and beta positive. How does that work? So first we are going to discuss beta minus decay. How does that work? So we have carbon 14 जिसका ये structure given है, ठीक है? और नाइट्रोजन का, तो ये कार्बन ने emit किया किसको? बीटा नेगेटिव को, which is 0 - 1. तो हम देख सकते हैं कि 14 तो 14 ही बना. There is no difference in that. But 6 changed to a 7 with the release of beta positive, beta negative, which is 0 minus 1, which is again plausible. कि -1 plus 7 करोगे तो दोबारा 6 ही बनेगा. So we understand that idea. And this is what we were working with in beta decay जब हमने पहले beta decay को पढ़ा था. But what's special about this? What are we supposed to do in this? We're supposed to learn about the changes in quark composition. You see, if you observe in this, they had 6 protons previously. Now there are 7 protons. So ये कैसे हो सकता? How can this be possible? So the actual mechanism, what has actually happened inside the nucleus, something goes like this. So a neutron is believed, of course not believed, but we have understood that now, is broken down or breaks down to become a proton. Sorry, it becomes a proton with a value of 1, 1, and also becomes a beta particle. Now, proton stays inside the nucleus and beta is emitted out of the nucleus, which is what you see as an electron or beta radiation or beta emission. What was the problem during beta radiation? You see, they could figure out that the energy of the reaction is same, right? By using E equals to mc squared, they could figure out the reaction of the energy was same. But this energy was not same for electron. The energy for beta was sometimes higher, sometimes lower than expected, sometimes even higher. It was fluctuating. It was not constant, but the energy of the reaction was constant. That is how they realized that there's something missing. ये energy कोई ना कोई और share कर रहा है. मिसाल के तौर पे, let's say that the energy of the reaction is 10 joules, which is a very, very high number considering the atomic level or atomic scale of this. But anyways, so they knew that the energy is 10 joules by using E equals mc square. But when they calculated the energy for electron, they sometimes found that this is 6, sometimes it's 5, sometimes it's 7. So who's the rest? Where is the rest of the energy going? बाकी energy कहाँ जा रही है? क्योंकि law of conservation of mass energy के according क्या है? The energy before and after should be same. So then they figured out that something else is sharing that energy. So it's possible that this is 4, this is 5, this is 3. That something else was discovered later as an antineutrino particle. So this fluctuating energy of beta or beta emission actually led to the discovery of antineutrino, or at least led to them, told them that there is something else. इसने उनको बताया कि कुछ एक्स्ट्रा भी है जो उसको आप ढूंढ नहीं पा रहे, और अभी आप उसको ढूंढेंगे तो पता चलेगा कि टोटल एनर्जी बराबर कैसे होगी. So fluctuating energy was the reason that they discovered, or at least they went in the direction of finding antineutrino. So when you write this equation of mechanism, you also mention the equation of antineutrino, which is represented by 0, 0 with a symbol V but a dash, because it's an antineutrino, and beta negative के साथ हमेशा anti ही निकलेगा. ये इसका memory point है. सही है? Now we go back to the, और दूसरा फिर आ जाता है quark change. कि what has changed at the level of quark. So if we go back to protons and neutrons, what we've memorized, proton is made of up, up, down, and neutron is up, down, down. We've memorized this, right? So this is going to be a straight away MCQ. So neutron is made out of 1 up and 2 downs, and proton is made out of 2 ups and 1 down. So he says what changes, the question generally is what changes or what quarks are changed during a beta negative decay. So up remains up, a down remains down, but a down changes to an up. So कौन सी दो नई बातें हमें पता चली कि एक down quark changes to an up quark, ठीक है, and an antineutrino is released. These two things are different from O levels, right? And you're supposed to memorize this mechanism as well, that a neutron decays to become a proton, proton stays inside. That's why ये 6 proton से 7 proton कैसे हुए? क्योंकि एक न्यूट्रॉन टूटा, प्रोटॉन अंदर ही रह गया, तो उसने प्रोटॉन नंबर बढ़ा दिया, ठीक है, और बीटा नेगेटिव जो है वो इमिट हो गया. Similarly, if you move on to this beta plus decay, which is a positron decay, तो क्या हुआ हमारे पास यहाँ पर, ठीक है, this is actually 6 by the way, सही है. तो जो आपके पास positron होता है, ये आपके पास this is carbon. So carbon actually decayed to become this boron, right? So what would this become? So what is being released? Positron, which is 0 plus 1, right? So जब आप इसको और इसको compare करोगे तो आपके पास दोबारा क्या बनेगा? यही चीज बनेगी, ठीक है. This is going to be 4 probably. Yes, this is 4. So this is plus 1, 4. तो ये क्या बनेगा दोबारा? 5, ठीक है. तो इसमें आपके पास क्या हुआ कि यहाँ पर जो आपके पास decay आ गई वो आ गई beta plus की. So beta plus is being decayed. Anyways, and the pair particle of this is neutrino. So this is actually beta 0 plus 1 and a neutrino with 0 0 but no dash because it's a neutrino, not an antineutrino. पर अगर हम इसमें भी देखें तो what's actually going to change? What will change in this primarily? ठीक है. So a proton actually breaks down to become a neutron, which is 1 0, releasing a beta positive, which is 0 plus 1. तो अगर आप इसका before and after देखोगे तो same आएगा. यहाँ पर again quark change क्या होगा हमारे पास? Up, up, down, and up, down, down. So up remains an up, down remains down, but up changes to a down. So up changes to a down quark. ऊपर क्या हुआ था हमारे पास? Down जो है वो up में change हो गया था. ठीक है? So these are the things that you're supposed to memorize for beta negative and beta positive decay. And let's go back to the syllabus. Do we understand these things now? We understand the quark composition during beta and negative. Yes, we do. We understand electrons, neutrinos, fundamental leptons. Yes, we understand that they belong to the lepton family, right? हमें ये भी पता है. And how they are actually electron के साथ कौन है? Electron के साथ या beta के साथ कौन है? Antineutrino. और positron के साथ कौन है? Neutrino. ये memory based points हैं, ठीक है? और if we go back to the starting point of the lesson as well, जहाँ पे हमने इसको miss किया था, over at this point in the previous part, that we understand that what is particle and antiparticle, and positron is actually an antiparticle of electron. This is what we discussed in the second part of the video, in this part of the video as well. ठीक है? State that electron has antineutrinos and produced during beta negative decay are neutrinos, ठीक है, produced during a beta positive decay. Antineutrinos किसके साथ है? Beta negative के साथ. और neutrino किसके साथ है? Beta positive के साथ. ये भी बात हम अभी कर चुके हैं. This is what we've already discussed in this part of the course as well, right? और part number 10 हमारे पास क्या था कि alpha particle जो है उसकी discrete energy है. Beta has continuous range of energies because of anti and neutrinos or antineutrinos. This is what we discussed, that what led to the discovery of antineutrinos or neutrinos, because energy same थी, लेकिन beta particles की energy कभी ज़्यादा आ रही है कभी कम आ रही है, constant नहीं है. अल्फा की एनर्जी कंसिस्टेंट है. इसका मतलब है उसके साथ कोई और एक्स्ट्रा एनर्जी शेयर करने वाला पार्टिकल नहीं है. बीटा नेगेटिव और बीटा पॉजिटिव के साथ न्यूट्रिनोस मौजूद हैं. दैट्स व्हाई वी एक्चुअली ट्राई टू फाइंड देम इन द फर्स्ट प्लेस. Let's move on to this question. He says beta negative decay changes take place in quark composition. Nucleus emits beta negative. Which other particles are emitted? So beta negative है तो एक तो एंटी न्यूट्रिनो निकलना है, बिकॉज हमें पता है कि इलेक्ट्रॉन या बीटा नेगेटिव के साथ कौन है? एंटी न्यूट्रिनो है. तो हमारे पास एंटी न्यूट्रिनो ने तो आना ही था. क्वार्क चेंज में क्या होगा? व्हाट इज द क्वार्क चेंज इन बीटा नेगेटिव डिके? इट चेंजेस फ्रॉम डाउन टू अप. सो अ डाउन चेंजेस टू एन अप. सो ऑप्शन ए इसका आंसर था. आपके सामने इट्स मेमोरी बेस्ड क्वेश्चन. इसमें कोई सोचने वाला काम नहीं है. इट्स प्योरली बेस्ड ऑन मेमोरी. ठीक है? अच्छा, आफ्टर दिस वी हैव व्हाट कंसिस्ट ऑफ लेप्टॉन्स ओनली. तो हमें पता है कि फ्रॉम द फैमिली ऑफ लेप्टॉन्स वी हैव, अगर लेप्टॉन फैमिली पे आप आ जाओ तो वी हैव इलेक्ट्रॉन्स, न्यूट्रिनोज, एंटी न्यूट्रिनोज, पॉजिट्रॉन्स. ठीक है, ये है ना हमारे पास. तो इसमें हमारे पास अब हम उसको फिगर आउट करेंगे. इलेक्ट्रॉन भी है, न्यूट्रिनो भी है, पॉजिट्रॉन भी है. इलेक्ट्रॉन, न्यूट्रिनो, प्रोटॉन जो है वो हेड्रॉन है. इलेक्ट्रॉन है, प्रोटॉन हेड्रॉन है, न्यूट्रॉन भी हेड्रॉन है. न्यूट्रिनो इज अ लेप्टॉन, न्यूट्रॉन इज अ हेड्रॉन, पॉजिट्रॉन इज अ लेप्टॉन. तो ये दोनों तो हैं, ये नहीं है. तो ऑप्शन ए ही है जिसमें तीनों लेप्टॉन्स हैं. ठीक है? अगेन मेमोरी बेस्ड क्वेश्चन. Now it tells you beta negative decay, ठीक है, and an antineutrino, we also know that. So again वो कहता है quark composition. तो देखिए beta negative decay में हमने क्या याद किया mechanism? A neutron disintegrates to become a proton. So neutron disintegrates to become a proton. Neutron बना किस से? It has only one up and two downs. तो option C और option D तो गलत हो गए. Then we have down, one down and two ups a part of proton. So A and B दोनों ठीक लग रहे हैं. But let's move on towards the type of force. So weak interaction, weak nuclear force is the cause of beta negative decay. This point is also from O-levels and IGCSE. So again, I can only emphasize enough that you have to go back to O-levels and memorize all of these points. But this is just one extra point. That's why I've included this MCQ in the part of this lesson as well, that beta negative decay occurs because of weak nuclear interaction. You might be thinking, what is the strong nuclear attraction or interaction? This is basically the strong nuclear force which tries to, or which is trying to hold everything place in one single place inside the nucleus. You see, सोचने की बात है कि अगर मैं एक न्यूक्लियस को ऑब्जर्व करें, हीलियम को ले लें, it has two protons and two neutrons. What's keeping them together? What is holding them together? ये हम अपने इंसानी के लिए तो बना लेते हैं कि बाहर एक शेल बना हुआ है, बट असल में तो शेल नहीं होता न्यूक्लियस के बाहर. There is no shell, there is no enclosing, there is no enclosure outside the particles of the nucleus. So where does it come from? और दूसरा, जो प्रोटॉन्स हैं इन पे तो पॉजिटिव चार्ज है, they are repelling each other with a very high electric force, but why are they not successful in doing so? ये एक दूसरे से दूर क्यों नहीं जा पा रहे? Because something from the outside is holding them back, something from the outside is trying to still push them together, and that is known as strong nuclear force, strong nuclear interaction. This is what you're trying to overcome when you try to break apart a nucleus to become its nucleons, and this is what you're trying to overcome when you're trying to do a fusion reaction. कि ये एटम किसी और के साथ फ्यूज कर जाए, क्योंकि उसके अंदर भी पॉजिटिव और पॉजिटिव हैं, दोनों एक दूसरे को रिपेल करते हैं, दे आर ट्राइंग टू रिपेल ईच अदर. दैट्स व्हाई फॉर अ स्ट्रॉन्ग न्यूक्लियर फॉर अ न्यूक्लियर फ्यूजन रिएक्शन, to fuse them together, to combine two nuclei together, you need a very high temperature and very high pressure, because to overcome the static repulsion of two positively charged nucleuses is very difficult. Okay, all right.